All right. Electrolytes. Now, what's the first thing that comes to your mind? It's the first thing that came to your class's mind when you hear the word electrolytes. Gatorade. Everybody says Gatorade. Yeah. And what does Gatorade? What does electrolytes do for you? They give you what?
Energy.
Energy. Absolutely. That's completely and utterly wrong. Everybody's wrong about this. Yeah. This is a problem here. We all have. It's one of those things where. By the way, I'm going to use an electric light to talk about electrolytes.
Oh, I'm so clever.
But it is, yeah, it is. I am pretty clever. But the thing is, if y'all look here, Nikki? Oh, yeah, she will be watching this. Yeah, tell Nikki she missed the second half if she's watching. It's down a little bit. All right.
We don't have to give a shout out.
You watching here? Shh. Watch. Now, I'm going to take some water. Y'all watching this? I've got some plain old water, and I should explain what this is too. This is a bowl, but the wire that's plugged in right here has been broken. So each of these prongs, okay, these two prongs, have a wire inside of the plastic on the outside, so I don't kill myself. I could touch the plastic. But if I were to push those two prongs together and touch the two wires, it would complete the circuit and it would light the light bulb, like you would normally have a lit light bulb. Now, I'm going to take some water and pour it into this cup, and I'm going to put it underneath there. Now, if that completes the circuit, it will light the light bulb. What do we all know about water? We've all been warned about water. What should you not do in a lightning storm?
Go in the bathtub.
Go in the bathtub or go swimming, right, in your pool. Why not? What does water do? It conducts electricity. So when I put this across here, it's going to complete the circuit, and the light bulb is going to light.
Just
yeah, your parents are idiots. You can go swimming whenever you want to. Water doesn't. Maybe I didn't put enough. Let's see.
There's an alarm going off.
There's an alarm going off back there. It's okay. It'll stop.
Oh, this is
What? What's going on here?
I don't know what is going on, Mr. Allen.
I don't know. Well, here's the problem. We've been lying to you. As your parents, we've been lying to our kids for a long time. Yeah. Basically, water doesn't conduct a very good current. I mean, it conducts a current, but not really well. In fact, I'm going to have to shut that stupid one. As soon as I get back there, it's going to stop. You know that. One of those stop ones.
Yes. Takes out everyone.
Thank you. All right. That'll be again probably in a minute. All right. Now, our parents we weren't really lying to you, but it's like kind of like your electrolyte answer about giving you energy. It's not really correct, and this isn't really correct too. Water is actually not a great conductor of electricity. It does conduct a little bit. Matter of fact, if I were to put my finger in this right now, I'd know it. Okay, I've actually done that. I've actually tried while I was cleaning off a wire, I was swirling it, and it swirled up to the top and hit my hand, and I would feel it. You'd feel the current, but it's not a good conductor. Not good enough to even light the light bulb. However, when you're dealing with a pool water or a pond water or a bathtub water, you're not swimming in distilled water. If I add something to this, let's see what happens. Let's say I add a little bit of salt to it, which I had right here a second ago. Here it is. All right. So if I add a little salt, okay. Now if I add some salt to this, and stir this guy up, and nothing seems to be where I want it today. Stir this guy up. Now let's see what happens. Because like I said, water is not a great conductor of electricity, although you still shouldn't swim in it because first of all, you're not swimming in distilled water. You're swimming in water that has lots of ions in it. All right, but you're also the amount of electricity in lightning. It doesn't have to be a great conductor, and it's still going to kill you. So it doesn't really matter. Okay. You really shouldn't go swimming in a thunderstorm. However, as you can see here, this guy, salt, is a good conductor at this point. He's a strong, what we call a strong electrolyte. He's a guy that breaks up in solution and forms and conducts an electric current because it forms ions. I think you can still see that with the bulb there. Hey, wait, look. Wait, watch. I had an idea. Get it? Light bulb. I had an idea. All right. What we call guys that break up into ions in solution and conduct a good current strong electrolytes. Now, I want to kind of talk about another thing, what I said a minute ago about how you guys are wrong about not just water not being a very good one, but about, you said Gatorade is to give you energy. It's electrolytes that give you energy. That's really not true either. Take a look. Here's some hydrochloric acid, which is a strong acid. And if I put him on here, watch how brightly this bulb burns. It's even brighter than the last one. Okay? All right? Matter of fact, I want to wash him off because I don't want water. I mean, I don't want the acid to stay on there. So I'll wash him off a little bit. Sometimes it stays on those metal, kind of sticks to it, and will corrode them. But it's not the electrolytes that are giving you energy. Okay? The electrolytes are helping to conduct the current in your body. Your bodies are big electrical machines. And you're getting your energy from what in the Gatorade?
Sugar.
The sugar. Yeah, the sugar. The sugar is giving you the energy. The electrolytes are replenishing the stuff that you're losing along with your energy that you're burning from burning your own sugar that you have in your body. When you sweat, you're losing salt, you're losing sodium ions and chloride ions and potassium ions and all kinds of ions. You're losing all these things. And you need those. They're all used to actually conduct currents in your body. That's how nerves, our transmissions are happen along your, and that's why what'll happen if you get exercise too much. Yeah, you get weak from a lack of energy, but you also get weak from lack of ions. The ions basically are you can't conduct currents as well, and you can't conduct electricity as well, and you're losing too many ions. You can pass out, you can get weak, you can get shakes. Have you ever exercised so much in hot weather you actually shake? All right, it's not just because you're out of sugar. You're out of energy. All right, it's also because of the imbalance of electrolytes in your body. It's doing it again. It's that stupid thing. Anyway. All right, well, let me go back and throw that one out and step on it. I don't know how to shut this thing off.
Take out the battery.
Smash it.
You guys you're all full of ideas. There is no battery, number one. Smash it, number two. That's good. The battery is not replaceable. Great ideas. All right, so anyway, back to strong electrolytes. Guys like hydrochloric acid, which is a strong acid. We're going to talk about the difference between strong and weak acids. Keep this in mind for just the next chapter. We're going to come back to that. I'm not going to do this again, but remember that I took hydrochloric acid and it actually lit the light bulb even better than salt did. But those are some examples of guys that dissociate completely into ions in solution, and therefore they conduct a current. Because to get a current going, to complete a circuit, and to have the flow of electricity, you basically have to have two things. You got to have charged particles. Usually in a wire, that's just electrons, but it could be ions, like it was in my solution. And they have to be able to move. They have to be able to be moving. Okay. That's why, if you remember back to my demo, back to the video we did, if I just put the plain old solid salt up there, I'm not going to do it. Is it going to conduct a current? No. I have charged ions, I've got salt, sodium, and chloride, but they can't move. All right? When I put them in water, they can move, and that's why it conducts a current. And that's a good example, like along with hydrochloric acid and any soluble ionic compound. Now, that's going to be one of the questions they're going to ask you on the test and on the worksheet or whatever else I give you. You will know this will work. You will know you'll have a strong electrolyte if I give you an ionic compound and you can look him up and he says soluble next to it. If he's soluble and he's ionic on this sheet, you see the ion, potassium nitrate, whatever. He will conduct an electric current. He will be a strong electrolyte if he's very soluble in water because he's already got the ions and now he can move. Now, let's take a look at this next guy I want to do. Take a look at him. Now, we just did hydrochloric acid. Let's do another acid, but not anywhere near as strong an acid. We're going to take some vinegar. So here's some vinegar. And I want to put him across this wire, across this bulb too. Okay? Now, I may have to move this one a little closer because, and turn that light off because it won't be as obvious, this one. Okay? Both of them off, yeah. Now, when I put this one underneath, I hope you all can see, just barely lights that light bulb. See it? If I stand up, I can see the thing. You can turn it off, on. You can probably see it from where you are with the lights off, right? Okay. This is what we call, turn the backlight on, a weak electrolyte. Vinegar is a weak electrolyte. It's also a weak acid. He will conduct a weak electric current, but there's something wrong with him. Something wrong with you people too. But there's something wrong with him. He doesn't dissolve completely, break up completely into ions in solution. It only partially dissolves. I have in the past tested, and you can see it yourself if you wanted to, but if I have in the past tested orange juice, lemon, grapefruit, any kind of citric acid is going to do the same thing. Okay? It's going to barely light the light bulb. It dissolves into ions, but it's not as strong as a strong electrolyte like hydrochloric acid. All right, so some examples would be vinegar and any citric acid you have, like fruits, oranges like that, pineapple, will conduct a current. Now finally, we have guys like this. Let's take a look here. Remember what I told you we needed. We needed two things for our electrolytes to work. We need the stuff to dissolve in water to be able to move, and we also need them to be charged. Let's try another guy that we know dissolves in water. Okay? Let me try a little bit of my sugar. Let me see what bag of sugar I have around here. Here it is. All right. Now,
I look brand new.
yeah, how about it? This is why we never eat stuff in the lab. This bag is probably about, well, it probably is older than most of you. And I'm not exaggerating on that. I really do believe it's older than most of you. All right, take some water. I'm going to add some sugar to it. Okay. Now everybody knows, like salt, sugar is very soluble in water. Swirl it up, stir it up. And I'm going to put him in here. Now let's watch what happens. Nothing happens. Well, sugar dissolves in water. Why do you think it's not lighting the light bulb?
It has a weak very weak electrolyte.
Well, even though
No electrolyte.
it's not even a weak electrolyte. It's a non-electrolyte. This guy does not form ions in solution at all. Sugar dissolves well enough, but it doesn't actually form ions in solution. He's a molecular solute, and he doesn't actually form ions. So, even though the sugar molecules are free to move around, they're not carrying a charge. These guys don't conduct a current either because they don't form ions or they don't dissolve. And that brings us to this next and last example. I'll show you here.
They don't want
Our last example, I want to take some calcium carbonate. Now, calcium carbonate, if you look him up, I mean, if you were to draw the formula for him, draw the equation or the ion charge and everything, and write out the correct formula for him, you would find the calcium carbonate, which I'm just adding to here, and I'm going to stir it up. Is an ionic compound. Calcium ions, carbonate ions, +2, -2. But when I put them in here, nothing happens. He's also a non-electrolyte. Now that seems strange. A minute ago, we just said sugar was a non-electrolyte because he didn't form ions. Can anybody see why this guy probably is a non-electrolyte? It didn't dissolve. He didn't dissolve. You see that? By the way, this is kind of weird. Back before this class, remember the lab we did with the qualitative analysis stuff, little wells? Remember how we originally thought when we saw a guy like this, it said, oh, that guy's the one who dissolved, and the ones that were clear are the ones that didn't. That was the exact opposite. The guys that are cloudy like this means that they don't dissolve in water. The guys that are clear, when you add them in there and you don't see them anymore, they're the ones that did dissolve. And a lot of times people get that backwards for whatever reason. Now here's a neat little trick here. Watch this. You watching? I'm going to take a non-electrolyte, and I'm going to add a weak electrolyte. This is vinegar. Together. Now, a non plus a weak. What would the things happening there? Well, take a look. First of all, what's happening? You'll probably see it. Fizzing. So there's a chemical reaction going on here too. A non plus a weak gives me a stronger electrolyte, which kind of doesn't make sense, but it will if you think about it. If you look up calcium carbonate, what do you think's happened? What was the problem? Calcium carbonate had the ions there, but they weren't dissolved, right? So what do you think happens when I add the vinegar to it?
Since it's an acid, it dissolves in the carbonate.
Yeah, exactly. Now I've got calcium ions, and I've got those ions that are able to complete the circuit. And so it lights the light bulb even better than the vinegar did, right, which is a weak electrolyte. And certainly better than the calcium carbonate, which is a non-electrolyte. So some examples of non-electrolytes: sugar, calcium carbonate, any insoluble non-polar compound. Any insoluble or non-polar compound. Why would non-polar automatically not work? They're not charged, exactly. And if you don't have any charges, you don't have any ions, it ain't going to work. All right.